Okay, system development life cycle. So look at the approaches to system development. Approaches to system development. So under this, there are quite a number of stuffs we are going to look at. To look at introduction, then the system development life cycle or software development life cycle. We'll look at the system development phases, the life cycle phase diagram. Then we'll explain the system development phases and also consider the system development life cycle phases with management control. Then we look at the advantages of the system development life cycle model. Then there are the disadvantages. Then we'll go further to basically look at work breakdown structure. If you want to develop a system, how do you break down your work? Then you look at the iterative and incremental development model. Then also look at this development process. Then we'll also look at extreme programming. Okay, what is extreme programming? This will also be covered in this unit. Then we'll look at the RAD or rapid development model. Okay, looking at the practical application of the RAD model, the advantages of the RAD methodology, disadvantages of the RAD methodology will also be considered. Then we also consider unified process model and its characteristics. Then use case driven, the architecture centric, risk focused, inception phase, elaboration phase, construction phase, and so on and so forth. Then you also look at the evolution of software process model by focusing on the incremental model. Then we also look at the spiral model, its advantages as well as disadvantages. Then we also look at concurrent development model and also summary. Okay, so this is what we are going to cover. Okay, so with that said, I think we are good to go. We are good to go. Thank you. System development life cycle. What comes into your mind, Mr. Makung? Okay. So in short, we're just talking about the steps that are involved in developing a software. Okay. That is the system development life cycle. Okay. So we're talking about the steps that are involved in system development. Okay, so we are saying it includes the guidance, because by guidance we are talking about the steps that are there to guide when it comes to system development. Then there are what we call policies. Okay, government, the organization should have policies. The organization should have policies and procedures that guides in coming up with new systems. You could have the system in place, but the organization need to have the procedures in place that will guide them on how they come up with the new system. Okay, so then we of course this one will include how do you go about gathering the requirement specifications, which could be both functional and non-functional. Then after you've gathered your requirement, how do you go about designing, coming up with a design? Then the aspect of implementation, testing. How do you go about testing? How do you go about deployment? Do you deploy just at once or you deploy in parallel? Okay, how do you go about that? So all these are procedures that must be put in place, because you can imagine you develop there's a there's an organization that uses a manual system, and then all of a sudden, let's say you want to migrate them to a digital system, and then you just stop them from using the manual system automatically, then that will be a problem. So you need to come up with a plan on how you can be able to use this, more like to migrate, probably in parallel, so that until users are very much conversant with this system, that is when they'll be able to make use of the other system. So that is, all these must be put in place. Okay, so the system development life cycle or software development life cycle. We are saying in system engineering or information systems and software engineering, we're saying software engineering is the process of creating or altering systems, and the models and methodologies that people used to develop these systems. Okay, so the concept generally refers to a computer or information system. So when you deal with, you talk about system development, this concept is always associated with the software development. So it's associated with the software development. Okay. So now, what is the SDLC? This is a process used by system analysts to develop an information system, okay, including requirements, then validation, training, and the user stakeholders ownership. Okay. So in short, you are saying it's a process used by systems analysts to develop an information system, Mr. Mako. So in just to develop an information system. So in short, that is what system development life cycle is. It's a process used to develop an information system. Now, as this is a process, it means there are quite a number of steps or stages that are involved. Okay, so what we are saying is that um, there's an aspect of requirement gathering or requirement collection. You have to collect and analyze the requirement, then you validate these requirements before you venture into the aspect of system development. Now, once you develop the system, there is an aspect of training. You need to train the users. Okay, once the users are trained so that they can have ownership, then they will be you can be able to deploy. Now, requirement specification, like we saw earlier, is that it is a very important aspect of software development, because you have to involve the users. Okay, so if users are not involved, if you don't involve the users, okay, then it means the users will not use your system. And if users do not use the system, or it means it is a failed system. Okay, it is a failed system. So any system software development life cycle should result in a high quality system that meet or exceed the customer expectations, reaches completion within time and cost estimates, work effectively and efficiently in the current and planned information technology infrastructure, and is inexpensive to maintain and cost effective to enhance. Cost effective to enhance. So this is what we are saying. So the system developed should exceed the human expectations. It should exceed the human expectations. That's what we are saying. For example, a computer systems are complex and often, especially with the recent rise of service-oriented architecture, computer systems are often linked multiple tradition systems potentially supplied by different software vendors. So to manage this level of complexity, a number of system development lifecycle models have been created. Okay, so there are a number of SDLC models. Prominent ones include the waterfall model, we have the fountain, we have the spiral model, we have the build and fix, then we have the rapid prototyping or rapid development, then we have incremental and synchronized and stabilized. So these are some of the models that have been developed to help us in software development. So the system development life cycle is a type of methodology used to describe the process for building information system intended to develop information system in a very deliberate, structure, and methodical way, reiterating each stage of the life cycle. Okay. So in a software development life cycle, SDLC, it is, we're saying it's a methodical way, a proper and organized way of developing a system whereby each of the stages involved in software development is accounted for. Okay. So the system development phase or phases. So system development life cycle adheres to an important phase that are essential for developers. Okay, and these phases include planning, analysis, design, and implementations. And I explained in the sections below. So we are talking about the stages that are involved in software development. The most critical ones involves planning, then there's analysis, there is design and implementations. Planning, analysis, design, and implementation. Yeah. So several systems development lifecycle models exist, the oldest of which originally regarded as the system development life cycle is the waterfall model. Okay, the waterfall model is the oldest. Okay, so a sequence of stages in which the output of each stage become the input to the next stage. That is how the waterfall model operates. Okay, the output from each stage, which stage? Planning, analysis, design, and the implementation, becomes the input to the next stage. Okay, so these These stages generally follow the same basic steps, but many different waterfall methodologies give the steps different names, and the number of steps seem to vary between 4 and 7. The number of steps seems to vary between 4 and 7. Okay, so that is software development life cycle phases diagram. We have what we call problem definition. Of course, planning is here. Okay, planning is considered to be among here. It's considered on problem definitions because you need to define and identify the problem in your planning aspect. Okay, then you analyze. That's an aspect of analysis. Then from the analysis, there's design. Then there's implementation. From implementation, you have validation and then evaluation. Now you evaluate. If it meets the user requirement, then you can deploy. But you can deploy. But if it doesn't, then you go back to problem definition, analysis, design, implementation, validation, and evaluation. So it's an iterative. Okay. So let's look at the explanation, requirement gathering and analysis. So the goal of systems analysis is to determine where the problem is in an attempt to fix the problem. Okay, so that is the goal of um, system analysis. To analyze, you have this system, now you analyze, you are trying to analyze it. So the goal is basically for you to identify where the problem is so that you can be able to fix it. You cannot fix the problem which you are unable to identify. So the first thing you need to do is identify the problem. So this step involve breaking down the system in different pieces to analyze the situations. So analyzing the project goals, breaking down what needs to be created, and attempting to engage users so that definite requirement can be defined. So I'm talking about decomposition in computing. Okay, so requirement gathering sometimes requires individuals or teams. So we are saying this is a very critical aspect of software development. When developing software, requirement elicitation or requirement gathering is very important. It's a very important undertaking in a sense that it helps in analyzing, in identifying the problem that is there. Okay. Once you gather these requirements, you'll have to analyze them. Okay. Through the analysis, then you'll be able to identify to say, okay, the problem which is here is this and that. And now we are saying you can conduct this exercise as an individual or as a team. Okay. That's requirement gathering. From client as well as service provider side to get detailed and accurate. So you have to ensure that you get the details. Only upon getting the details will you be able to provide a clear and clean analysis of the information of the system rather. Okay, that's the analysis, requirement gathering. Now design, what happens here? Uh, in system design, functions and operations are described in details, including screen layout, business rules, process diagrams, and other documentations. So the output of this stage will describe the new system as a collection of modules or subsystems. In short, what you are saying that after you have gathered all these requirements, the next thing to do is you come up with a design. The design is more like an architecture, okay, of what constitute the modules, what constitute the relationship among the modules, and so on and so forth, because this will be part of the entire system. Okay, so the design stage takes as its initial input the requirement identified in the approved requirement documentation. That is the input. It takes into consideration the requirement. If you mess up the requirement, then even the design will be messed up. Okay. For each requirement set, a set of one or more design implements will be produced as a result of interviews, workshop, or prototype effort. Okay. So design element describes the desired software features in details and generally include the functional hierarchical diagrams, screen layout, tables of business rules, business process diagrams, pseudocode, and complete entity relationship diagram with a full data dictionary. Okay, so we expect once you start designing your system, we expect there to be all these aspects. We expect you to consider coming up with an entity relation diagram, data tables, the tables, okay, that will constitute the entities that are being identified. Then you should be able to have also the aspect of the data dictionary that will contain the details about the data that is going to be in the database. So these design elements are intended to describe the software in sufficient details that skilled programmers may develop the software with minimal additional input design. Okay, so that's what you are saying. If your design system, your requirement has been done, if your design has been done accordingly, what will happen is that you will have all this information and you'll be able to send it to a programmer. Okay, this person will be able to do the job with little or no other additional input. It's more like you are trying to build a house. What happens is that you get a plan, and once you get this plan approved, you can get this plan and give it to a builder or a bricklayer, and this bricklayer will always just make use of the plan and they'll be able to do the job. So that's the sure. Okay. When you talk about data tables, you're basically talking about the tables that will constitute your database. The tables that will constitute a database. If you are planning to develop a school system, a university system, you know quite well that there are a lot of entities that can be considered. You may have to look at the lecturers, you may have to look at the courses, you may have to look at the student, you may have to look at things like the payment and so forth. So what we are saying is that each table we could have each information to do with, for instance, lecturers should be in its own table called the lecturer table. Okay, then for student table and so forth, and then you can now draw all these tables in database terminologies. We call them as entities. We call them as entities. As a result, once these are there, you can now come up with what we call entity relationship diagram, which will give an overview of how the tables are organized and how they are related to each other through the aspect of relationships. Okay, so that is now from the design we have what we call the build. You build the system or the coding aspect. So modular or subsystem programming code will be accomplished during this stage. Okay, you build now based on the design. So unit testing and module testing are done in this stage by the developers. So this stage is intermingled with the next in the individual modules. In that individual modules will need testing before integration to the main project. So what we are saying is that this stage of building, the modules are built separately. They are built separately and tested. Okay, they are built separately and tested. Well, yes. Now, once they are tested, you build, let's say, the module for students. You test it. Is it working perfect? Wow, good. You move on further to look at the module for lecturers. Is it working properly? Good. And then after you've considered all the modules, then you can do what is known as integrated. You integrate the modules and then you test the whole system collectively. Okay, so that's what we are saying. And let's look at the aspect of testing. So the code is tested at various levels in software testing. Okay, we have what you call unit, system, and user acceptance testing are often performed. Unit and user acceptance testing are often performed. So this is a gray area. This is a gray area. This is a gray areas as many different opinions exist to what the stages of testing and testing are. Okay, to what the stages of testing are and how much, if any, iteration occurs. So iteration is not generally part of the waterfall model, but usually some occurs at this stage. So below are the following types of testing. Okay, so these are the various type of testing that you'll be able to find. Okay, these are the various part of the waterfall model that you'll be able to find. We have what we call data set testing, unit testing, system testing, integration testing, black box testing, white box testing, regression testing, automation testing, user acceptance testing, performance testing, production, and so on. So the definition, it is a process that ensures that the program performs the intended task. So that is about the testing. So the purpose of testing, we are saying testing is basically a process that ensures that the program performs the intended task. That is testing. Then operation and maintenance. Operation and maintenance, the deployment of the system include changes and enhancement before the commissioning, before the commissioning or a subset of the system. Okay, so before you deploy the system, we need to enhance it to ensure that it is working perfectly. So maintenance or maintaining the system is an important aspect of software development life cycle. As key personnel change position in the organization, new changes will be implemented which will require system update. Okay, so there are all these changes. We are saying once you implement or you deploy, there's an aspect of um, maintenance. If some changes takes place in the organization, okay, if some changes takes place in the organization, these need to be updated to the system without any problem or without any difficulty. What about system phases with management control? System phases with management control. So the system development lifecycle phases serve as a programmatic guide to project activity and provide a flexible but consistent way to conduct the project to a depth matching the scope of the project. So we are saying this is basically a way of um, uh, tackling a system development project. Now, each of the software development life cycle phase objectives are described in this section with key deliverables. Okay, so a description of recommended task and a summary of related control object for effective management. So what you are saying is that for each of the stages that we've discussed above, for each of the stages that we've discussed above, there are key deliverables. There are key deliverables that are needed to be accomplished for each of the stages. A description of recommended tasks and a summary of related control objectives for effective management. So it is critical for the project manager to establish and monitor control objectives during each software development lifecycle phase while executing projects. So control objectives helps to provide a clear statement of the desired result or purpose and should be used throughout the entire software development life cycle. So control objective can be grouped into major categories, which we are calling domains, and relate to the software development cycle phases as shown in the figure. Okay. We'll see the figure later of this control objective. Okay. Then we are saying to manage and control any software development initiative, each project will be required to establish some degree of a work breakdown structure to capture and schedule the work necessary to complete the project. Okay? To manage and control the any software development life cycle initiative, each project will be required to establish some degree of work breakdown structure. And this is there to capture and schedule the work necessary to complete the project. So the work breakdown structure and all programmatic material should be kept in the project description. Okay? Okay, this should be kept in the project description section of the project notebook. So you need to have a notebook that describes every activity of the project. So this is very important. Okay, so this is where the work breakdown structure and a programmatic material should be kept. So the work breakdown structure format is mostly left to the project manager to establish in a way that best describes the project's work. There are some key areas that must be defined in the work breakdown structure as part of the software development lifecycle policy. There are certain key areas that must be defined. So it is basically a process with the details that need to be considered. So the following diagram describes three key areas that will be addressed in a work breakdown structure in a manner established by the project manager. Okay, we have this diagram. Okay, this diagram is basically showing the software development lifecycle phases where we have the project definition, user requirement definitions, system requirement definitions, analysis and design, system building, okay, or coding, where we're talking about prototyping or just a pilot. Then you have implementation and testing and sustainment or maintenance. Now, these are control objectives. So you will find that the control objectives um, between project definition, user requirement, and system requirement definition, these falls under, when it comes to management control domain, under what is known as the planning and organization. Planning and organization. So those three stages falls under planning and organization. Okay, so they've been subdivided like that for the purpose of controlling the stages. Then we have system requirement definition, analysis and design. Okay, then these are under acquisition and implementation. This falls under acquisition and implementation. Then we have system building, prototyping, as well as implementation and training. Okay, and implementation and training. So this falls under the delivery and the support. Delivery and the support. Then we have sustain, sustainability or sustainment, implementation and training, sustaining, system building, prototyping, pilot, and analysis and design. These are all part of the monitoring. They are part of the monitoring. So this we are basically talking about the three aspects: the software development life cycle phases, their control objectives, and then the management control domain of the process. Advantages of software development life cycle model. So with an SDL model, developers will have a clear idea on what should be or shouldn't be built. That is one key important area. You definitely know what should be and what should not be built. Okay? Since you have the requirement and you have the design, which actually the developer can follow in terms of the development. Okay. Since they already have an idea on the problem that should be answered, a detailed plan could be created following a certain SDL model. So you can come up with a plan because you already have the idea of what really the problem is. Okay, what really the problem is, you already have the idea, so you can easily come up with the plan to solve that problem. So with an SDLC model, developers should even create a program that will answer different problems at the same time. Since everything will be laid out before a single code is written, the goal is clear and could be implemented on time. So you expect timely implementation because you have the requirement, you have a clear guidance or guideline on what needs to be done, because you'll have already gathered your requirements and understood the problem. Now, although there is a great possibility of deviation from the plan, a good project manager would take care of that concern. We said that a human being is not perfect. There could be some slight attempt to deviate from the actual plan, but since you already have the idea of what you want to achieve, you'll be able to prevent that from happening. Okay, so with a system development lifecycle model, programs built will have a clear documentation of development, structure, and even coding. The documentation will be very clear. In cases there are problems once the program is adopted for public use, the developers will always have the documentation to refer to when they need to look for any loopholes. So because of the clear documentation that is in place, because of the clear documentation that is in place, you always, in case of any problem that may arise as a result of deployment of this program out there, you always have a way to actually maneuver around. Okay, so you will always have to refer to the that documentation in order for you to fix the loopholes. So instead of testing it over and over again, which will stop the implementation of for a while, developers will just look at the documentation and perform proper maintenance program. Okay, so if you want to maintain, since this is divided into modules, so you can straight away go to the module and focus your attention on that module so that you do not disturb the process of operation that is already ongoing. So this means software development lifecycle will breathe more life to the diagram. Okay. So instead of frustrating developers in their work, if something goes wrong, software development cycle will make sure everything goes smoothly. It will also be a tool for maintenance, ensuring the program created will last for long time. The program created will last for a long time. Okay. What are some of the disadvantages? Thinking about the disadvantage of software development lifecycle model is like looking for a needle in the haystack. But the closest disadvantage anyone could think of software development lifecycle is the difference between what is written in paper and what is actually implemented. So this could be a major blow, okay, a major disadvantage, whereby you have something properly articulated on the paper, okay, something properly articulated on the paper, and when you give this to the developers, then you may have a situation whereby they don't follow it to the letter, And this could be a problem, a disadvantage. So there are things that are happening in the actual work that the paper doesn't see. Okay, so this gives a good impression for the client, especially for a third-party developers. But when the software is actually launched, it's on a very bad situation. So the actual situation of software development could be covered by fancy paperwork of software development lifecycle. It's more on documentation. You may come up with good documentations, but the aspect of the end product may not be as documented. Okay. So another disadvantage of a program, of a software that follows the software development program is it encourages stiff implementation instead of pushing for creativity in different software. So although there are several there are several there are models where programmers could apply their creative choices, it is always in the realm of what is needed instead of freely implementing. Okay, freely implementing what the developers think of necessary in the present environment. Okay, so this again becomes a problem. There's that aspect of creativity from the developers is basically not considered. Okay, there are so many things that could be done by developers if there are no boundaries or limitations in what should be developed. So many things could be done by the developer. So this is another issue. Okay, so these are the major disadvantages that are associated with um, the SDLC model. I think next time we next time for our next meeting we'll look at the work breakdown structure in um, yeah, we'll look at work breakdown structure in detail. Okay.